boys and girls, today we are going to learn something new about multiplication. This is Miss Milla and I want to teach you about commutative property of multiplication. Look at this picture. I have 2 times 3, it equals 6. And if I flip the numbers and I say 3 times 2, it still equals 6. That is the commutative property. Now let me show you. First, we're going to very quickly review what multiplication using arrays is. An array shows objects in equal rows, just like this, 3 rows of basketballs. It also needs to have the same amount of objects in each row. I have 5 items, 1, 2, 3, 4, and 5. Each row has 5. And finally, I use multiplication to find the total number of objects in an array. That means I'm going to count all of them by using what I just described. So 1, 2, and 3 rows, and each one has 1, 2, 3, 4, and 5 items. So when I write my numbers, it looks like this. 3 times 5, that's my 3, that's my 5 on my array, and it equals 15. That is the total that I have, and that is what we call the product. Now, let me show you what this means when I do the multiplication property of commutative. Commutative property of multiplication. Well, the commutative property of multiplication states that you can multiply factors in any order and the product or answer will stay the same. I have a 3 here, I have a 3 on the other side. I have a 2, and I also have a 2. And look at my answer. Both equal 6. In both cases, they equal 6. Look at the array. I have 3 rows, 1, 2, and 3, with 2 items each. And that equals 6. When I do 2 times 3, it's going to look different though. I have 2 rows this time, 1 and 2, and each one has 3 items. My array is a little bit different, but it still equals 6 flowers. And that is what this property means. It just represents things in a different way. It's going to look different, but it's the same product. Look at this example. This time I am multiplying 5 times 3, and that equals 15. Look at the array. I have 1, 2, 3, 4, and 5 rows, and each row has 1, 2, 3 items. It totals 15. And if I flip my numbers, I would have to say 3 times 5, and I'm going to prove to you that it still equals 15. Watch. So 3 times 5, this time I have 3 rows because it's 3 times 5, and each row has 1, 2, 3, 4, 5. So it's 3 times 5, and guess what? It still equals 15. That is the commutative property of multiplication. Let me show it to you another way. This time I'm going to make an array with squares. Let's say I have 6 times 2, and that equals 12. Well, my array is right here. But that can't be right. That's 2 rows. So I have to flip that array, literally. Now it matches. Look at it. I have 1, 2, 3, 4, 5, 6 rows, and each row has 2 items for a total of 12. Now, if I want to use the commutative property, I have to say 2 times 6. I just flipped the multiplication. Remember, this one is 6 times 2, and it equals 12. When I flip my numbers and I say 2 times 6, well, I'm going to have to flip my array too. If you thought I had to put it exactly this way, you are right, because I have 2 rows, and each one has 1, 2, 3, 4, 5, and 6. The answer is still 12, but my drawing looks very different. And that is the commutative property of multiplication. Finally, let's just read that one more time. The commutative property of multiplication means that you can multiply factors in any order and the product will stay the same. The factors are the numbers you are multiplying. So look at this example I have. It says 3 times 2, so I have 3 groups, and each group has 2 flowers. It equals 6. But if I flip my numbers, or factors, it says 2 times 3, so this time I have 2 groups, and each group has 3 flowers, and my total is still 6. Have fun using this property.